Now let's see the definition of critical section. It is a part of the program where shared resources are accessed by process. Based on this definition, 2 times gate questions are asked. So it's simple. They have given various options. What is critical section, right? So critical section is nothing but it is a part of the code where we are going to access the shared resources. For example, if the shared resource is a variable, then that part wherever you are going to use that shared resource, that is called as critical section. So if you write a program, now the program will contain like this. If you write any program, now that program will contain for some part no critical resource will be used, then that is called as non-critical section, right? And for some part maybe you'll use the critical section, which means you will say here you will say count plus plus, count minus minus, and something you will use it, then this is called as critical section, this part wherever you are using the shared variables. And then again there will be some part where you don't use it, then that is called non-critical section. And again there will be some part where you will use the critical section, that will be called as critical shared resources, that is called critical section. Therefore you can divide the program into various sections and into 2 types of sections. One section is called critical section and another section is called non-critical section. Now why should we divide the program like this is, as long as a process is executing the code which is non-critical, which means which does not involve any shared resources, you need not worry about it at all. Only problem arises when a process is in the critical section and when it gets preempted, and some other process which is also having a critical section which is using the same resource gets into execution, then at that point it might lead to race conditions, right? So what is race condition? See this. The order of execution of instructions defines the results produced. It is also asked in GATE. The question is like this: what is race condition, right? Or they ask this, right? If the speed of the processes define the output produced. Speed of the process means which process finishes first, right? If the speed of the process define the output produced, then it is called as race condition. Speed of the process means which one which finishes first. I told you in the previous example, if P1 finishes first, we are going to get some output. If P2 finishes first, we are going to get some output. That is called as race condition, right? Now if there are 2 processes, let us say this is process 1 and process 2, and 2 processes are having programs this way, and some part is having non-critical section and some part is having critical section, then the problem arises when one process is in critical section and it got preempted. Let us say this is critical section, this is critical section. One process P1 is in critical section and it suddenly got preempted, and other process P2 just entered the critical section, and both the critical sections are using the common variable something, count, right? Then what happens? It might lead to race condition. So just to avoid this, we are going to use something called as synchronization mechanisms. What is it? Synchronization mechanisms, right? So what is the synchronization mechanism is, now you place some code, some piece of code, you write small piece of code and you put it just before you are going to enter the critical section, and then you put other piece of code after you come out of it, right? For every critical section you do it, which means here also we do something, we put a code here and here we put a small piece of code, and this is called as entry section and this is called as exit section, right? And here also I am going to put the code. This is called as entry section and this is called as exit section, right? And if I put some pieces of code here in such a way that this code will help us in stopping or in allowing only one process inside the critical section. If P1 has entered the critical section by crossing this entry point, then the other entry point should stop P2, or in case if P2 is inside the critical section, then this entry point should stop P1 from entering it. For every critical section we should do this, which means I don't care how many times we have critical sections in the program, for every critical section we are going to put a entry and an exit point. Now using this entry point and exit point, we are making sure that only one process will ever enter the critical section, and the other process which will try to enter the critical section will be stopped by the entry point, right? So if you could somehow see that these pieces of code work that way as I defined now, then these are called as synchronization mechanisms. And there are various types of synchronization mechanisms. We shall discuss them. And then there are some requirements, which means whenever you write such a code, that should not create any more problems. Sometimes what problem might happen is CPU time will be wasted because of putting more code here, right? In such a, see, executing these lines is already a waste. Apart from this, some more CPU time will be wasted, right? I'll tell you how it is wasted. That is one problem. And second problem is sometimes they will not be able to stop processes entering into the critical section directly. Then the entire purpose is lost, right? That is called mutual exclusion. Mutual exclusion means critical section, okay, we shall see it, okay? And then the next one is sometimes because of these parts, this synchronization mechanisms, they will bring one more problem into this. Already we have one problem, that is race condition. Now these mechanisms, they will bring deadlocks into the picture. Deadlocks is both the process might get blocked because of these entry sections, and both of them will get blocked forever. So now there is a problem which is race condition. In order to solve it, we are going to introduce a solution which is called synchronization mechanisms. And now because of synchronization mechanisms, we might face some problems. I'm not saying that every synchronization mechanism is having this problem, but then there are various synchronization mechanisms, and each one is having its own advantage and disadvantage. In the sense, some synchronization mechanisms will waste a lot of CPU time, and some synchronization mechanisms will not provide mutual exclusion, which means at the same time two processes can enter the critical section simultaneously. And some synchronization mechanisms, they will lead to deadlocks. But then there are some good synchronization mechanisms which will solve all these problems. There are only few like that. And moreover, synchronization mechanisms are, even though they are first invented to solve this race condition, later they have been extended in such a way that using the synchronization mechanisms, we are even able to order the processes of execution of processes, which means we could even use the synchronization mechanisms and we could make the processes behave in certain way, which means P1 executes, then P2, then P1 executes, then P2, like this, right? So even though it is not invented, synchronization mechanisms are not invented to do that, we could even order the execution of the processes, reorder them, or we could even decide the way in which we want to execute the process. I'm going to take lots of examples on this synchronization mechanisms. Completely it is full of problems and it is very important coming to get, and even with examples you'll understand more, okay? So I'll take every possible example and I'll explain this. So don't worry if you didn't understand anything till this point. So keep watching, you'll understand with the examples, okay?